Hi friends, this is Naresh. This is my 8th lecture on design of bearings. Okay, in this session, I am going to explain about footstep bearings, collar bearings, and plumber block bearings. Okay, today I am discussing about these three topics. First of all, you have to know the fundamentals about loads on bearings. This is a shaft or journal, and this is the bearing. Okay, this is the assembled view of a shaft and bearing. The Yeah, there are three types of loads acting on journal bearings or bearings, thrust bearings or ball bearings. First one is the radial load. Second one is the axial load or thrust load. Third one is the combined load. Okay, these three loads are acting on shaft. Okay, first of all, I am going to explain about radial loads. Yeah, if the load acts perpendicular to the direction of the motion of the moving element is known as radial load. Okay. Yeah, the load is acts perpendicular to the direction of the motion of the moving element. Okay. This is a moving element. Okay. Yeah, the load acts perpendicular to the axis of the shaft. Okay. So this is the shaft. Okay. The side view of this shaft is like this, and this is the axis of the shaft. Okay, this is the axis of the moving element. Now this is the bearing. Okay, so here the load acts perpendicular to the axis of rotation of the moving element. That means the angle between this load and the axis is 90 degrees. Okay, here you can observe here the angle between axis of the shaft and load is 90 degrees. So when the load acts perpendicular to the axis of the shaft or axis of the moving element is known as radial load. Okay, this is called radial load. Okay, here the main load is perpendicular to the axis of rotation. Okay, axis of the moving element. Now coming to the axial load or thrust load. Okay, in this today's session, I will explain about axial or thrust loads with examples. Okay, if the load acts along the direction of the motion of the moving element is known as axial or thrust load. Okay, here the main load is parallel to the axis of rotation of the moving element. This is the shaft. Yeah, this is the axis of the shaft, and this is the bearing. Okay, here here the load acts along the axis of the rotation of the shaft. Okay, so here the angle between axis of the shaft and the load is 0. That means the load acts along the line, along the axis of the shaft. So this type of load is called axial load or thrust load. Combined loads. If the load acts perpendicular and parallel or inclined loads. Okay, then if the load acts inclined to the axis of rotation of the moving element is known as a combined load. Okay, this is a bearing. Now this is perpendicular to the axis, and this is the parallel to the axis. Here the load acts perpendicular to the axis of shaft and as well as along the axis of the shaft. So this both loads are acting at a time. Okay, this type of system is called combined load system. Okay, now types of thrust bearings. The thrust bearings are broadly classified into two types. Okay, footstep bearing or pivot bearings and collar bearings. These two are the examples for axial bearings. Axial bearings are thrust bearings. Okay, the thrust bearing is used to guide or support the shaft, which is subjected to a load along the axis of the shaft. Okay, such type of bearings are mainly used in turbines and propeller shafts. The thrust bearings are of the following two types: footstep or pivot bearings. Okay, and collar bearings. These two are explained in next slide. Footstep or pivot bearings. In a footstep bearing or pivot bearing, the loaded shaft is vertical. Okay, this is a shaft. Okay, this is a shaft. This is a footstep bearing. Okay, here the load is acting along the axis of the shaft. Okay, this is the shaft. This is the axis of the shaft. Here, this W is the load. Okay, here the load is acting along the axis of the shaft. Okay, for supporting this load we are using footstep bearing. This is the footstep bearing. Okay, in a footstep or pivot bearing the loaded shaft is vertical. Okay, this is a vertical shaft and the end of the shaft rests within the bearing. Okay, the one end of the shaft rests within the bearing. Okay, rest within the bearing. A simple type of footstep bearing suitable for a slow running, okay, slow running and lightly loaded shaft is shown in figure A. Okay, this is a simple type of footstep bearing. Okay, in order to compensate for end wear, the following two methods are employed. That is, a shaft is counterbored. Okay, a shaft is counterbored at the end as shown in figure A, and the shaft is supported on a pile of disc. These are the disc. Okay, this is the shaft. Okay, this is the axis of the shaft, and this is a steel disc. Okay, this second one is a bronze disc, and third one is steel disc. Okay, here the shaft is supported on a pile of disc. It is usual practice to provide alternate disc of different materials such as steel and bronze. Okay, steel and bronze as shown in figure. Okay, here we are using a steel disc. Then after we are using bronze disc, and finally we are using steel disc again. Okay, here totally we are using three discs. Okay, two are steel disc and one and middle one is a bronze disc. Okay, these discs are used to minimize the wearing. Okay, so that the next disk comes into play if one disk seizes due to improper lubrication. Okay, now coming to the collar bearings. This is the example for a collar bearing. Here in case of collar bearings the shaft continues. This is the shaft. Okay, this is the shaft and this is the axis of the shaft. Here the load is acting along the axis of the shaft. Okay, here small r is the radius of the shaft, capital R is the radius of the collar. These are these vertical rectangles are called collars. Okay, okay, the radius of the collar equal to capital R and the radius of the shaft equal to small r. Okay, in case of collar bearings the shaft continues through the bearing. Okay, the shaft may be vertical or horizontal. Okay, the shaft may be vertical or horizontal with single collar or many collars. Okay, these are called collars. Okay, uh, a simple multi-collar bearing for horizontal shaft is shown in here. Okay, the collars are either integral parts of the shaft or rigidly fastened to it. The outer diameter of the collar is usually taken as 1.4 to 1.8 times the inner diameter of the collar. Okay. Here the thickness of the collar is kept as 1/6 diameter of the shaft. Okay, 1/6 part of the shaft diameter. We consider the thickness of the collar. Okay, this is the collar. This is the This is the thickness of the collar. From here to here, this is the diameter of the collar. Okay, here the thickness of the collar we consider as 1/6 part of the 1/6 part of the diameter of a shaft. Okay, and the clearance between the collars as 1/3 diameter of the shaft. Okay, this is the clearance. Okay, the clearance here, uh, the clearance between collars as 1/3 diameter of the shaft. In designing collar bearings, it is assumed that the pressure is uniformly distributed over the bearing surface. Okay, here the shaft may be vertical or horizontal with a single collar or many collars. Okay, this figure shows a simple multi-collar bearing for horizontal shaft. Okay, this figure shows the simple multi-collar bearing for horizontal shaft. Okay, here the load is acting along the axis of the shaft. Okay, for supporting this load we are using the collars. Okay, now I am going to explain about solid journal bearing. Okay, these are the examples diagrams for solid journal bearing. This one is the bushed bearing. Okay, a solid bearing shown in here, uh, it is the simplest form of journal bearing. Okay, solid bearing is the simplest form of the journal bearing. It is simply a block of cast iron with a hole. Okay, this is the hole with a hole for a shaft providing running fit. Okay, the lower portion of the block is extended to form a base. Okay, to form a base plate or sole with the two holes to receive bolts. Okay, to receive bolts for fastening it to the frame. Okay, so this one is called a base. Okay, this base contains two holes. These two holes are used for screw fastening. Okay, now this is the solid hub. It consists of one hole. Okay, this hole is used for inserting the shaft. Okay, at the top of this hub having a oil hole. Okay, an oil hole is drilled at the top of the bearing for lubrication purpose. Okay, the main disadvantage of this bearing are uh, there is no provision for adjustment in case of wear. Okay, there is no provision for for adjustment in case of wear here. Okay, the shaft must be passed into the bearing axially. Okay, the shaft must be passed into the bearing axially, that is endwise. Okay, since there is no provision for wear adjustment. Okay, therefore this type of bearing is used when the shaft speed is not very high. Okay, not very high, and the shaft carries light loads. Okay, the shaft carries light loads only. Okay, this type of solid bearings carries light loads only. Now coming to the bushed bearings, this is the diagram for bushed bearing. Okay, a bushed bearing, as shown in figure, is an improved solid bearing in which a bush of brass or gunmetal is provided. The outside of the bush is a driving fit, in the whole of the casting, whereas the inside is a running fit for the shaft. Okay, when the bush gets worn out, it can be easily replaced. Okay, these are the bush. Uh, when the bush gets worn out, it can be easily replaced. In small bearings, the frictional force itself holds the bush in position. Okay, but for shafts transmitting high power, grub screws are used for the prevention of rotation and sliding of the bush. Okay, once again I repeat the topic about bushed bearings. A bushed bearing is an improved solid bearing in which a bush of brass or gunmetal is provided. Okay, here the middle portion of the bearing is called brass bush or gunmetal bush. Okay, the outside of the bush is a driving fit. Okay, in the whole of the casting, whereas the inside is a running fit. Okay, for the shop, when the bush gets worn out, it can be easily replaced. Okay, in small bearings, the frictional force itself holds the bush in position, but for shafts transmitting high power, grub screws are used for the prevention of the rotation and sliding of the bush. Okay, now coming to the another topic, that is a split bearing or a plumber block bearing. It is very important in our subject point of view. A split bearing is used for shafts. Uh, a split bearing is used for shafts running at high speeds. Okay, this is a example diagram for a split bearing or plumber block bearing. Okay, this type of bearings used for shafts running at high speeds and carry heavy loads. A split bearing, as shown in figure, consists of a cast iron base. This is a base. It consists of a cast iron base, also called a block or pedestal. This bottom base also called a block or pedestal. Gunmetal or phosphor bronze brasses. Okay, these middle portion, gunmetal or phosphor bronze brasses, bushes or steps made in two halves. Okay, two halves and a cast iron cap. Okay, this is a cast iron cap. This two halves called bushes. Okay, phosphor bronze bush or a gunmetal bush. Okay, the two halves of the brasses are held together by a cap or cover by means of mild steel bolts. Okay, these are the bolts. Uh, the two halves of the brasses are held together by a cap or cover by means of mild steel bolts and nuts. Okay, this is a nut. Okay, here we are using two nuts, and this one is called bolt. Okay, here we are using two numbers bolts and nuts. Sometimes thin shims are introduced between the cap and the base to provide an adjustment for wear. Okay, when the bottom wears out, one or two shims are removed and then the cap is tightened by means of bolts. Okay, when the bottom wears out, okay, one or two shims are removed and then the cap is tightened by means of bolts. Okay, the brasses are provided with collars. Okay, the brasses are provided with the collars or flanges on either side in order to prevent its axial movement, to prevent its rotation along with the shaft. The along with the shop, we are using four methods. Usually we are using four methods in practice. First one is this one is first method, this one is the second method. In first method, the shunts are, these are called shunts. The shunts are provided at the sides. Okay, these side edges are called shunts. Okay, the shunts are provided at the sides as shown here. Okay, and in second model, the shunt is provided at the top. Okay, the shunt is provided at the top, which fits inside the cap. Okay, which fits inside the cap as shown here. Okay, the oil hole is drilled through the shunt. Okay, this is a oil hole. So this oil hole is drilled through the shunt. Okay, this is a shunt. Okay, this is a shunt, and the middle line, the middle hole is called oil hole. Okay, oil hole is drilled through the shunt. Okay, and this is third model, and third method. This one is the fourth method. Okay, in third method, the steps are made rectangular on the outside. Okay, rectangular on the outside, and they made to fit inside a corresponding hole. Okay, as shown here. Okay, the steps, these are called steps. These steps are made rectangular. Okay, these steps are made rectangular on the outside. Okay, on the outside, and they are made to fit inside a corresponding hole. Okay, now in fourth method, the steps are made octagonal. Okay, here these are the steps. Okay, the steps are made octagonal on the outside. Okay, and they are made to fit inside a corresponding hole. Okay, here the split bearing must be lubricated properly. Okay, the split bearing must be lubricated properly. This is split bearing. Okay, we are having two shunts. Okay, 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 friends. Okay, in next class, I will explain about the different types of rolling contact bearings and ball bearings. I will explain about rolling bearings and ball bearings. Okay.